operating system lecture series. In today's video, what we have to see means we are going to see about what is a process scheduling and how the scheduling is done in the operating systems and also in our computer systems. So the main objective of process scheduling means we have to maximize the CPU usage. That we have to context switch between two processors should be maximized and to CPU for the time sharing systems. So the process scheduler selects among available processes for the next execution on the CPU. So this is the main job of the scheduler. They select the available processes for the next execution on the CPU. So it maintains that scheduling queues of the processes. So we have a different types of queues. One is a job queue. So the job queue, it have the set of all processes in the system. So in the job queue, we have the set of all processes in the system. It is called it as a job queue. Next is a ready queue. In the ready queue, set of all processes are residing in main memory and ready to execute and waiting in the ready queue. So that is the set of processes in the ready queue. Next is a device queue. The device queue contains a set of processes waiting for an input output devices. So these are all the set of queues are maintained in the any our system. So the processes are migrate among the various set of queues. Next, that is a structure of we have a different types of queue. So first, for ready queue and various I/O devices queue, suppose one process is created, that process have the PCB, that is a process control block. So for example, we have a process P2 and process P7. So that two processes are in the suppose ready queue இருக்குது அப்படின்னா, so the process P2 is comes first. So that is in that first in the queue. Next we have the process P7, and each queue we have a head and tail in terms of like data structure. You know that in the queue is represented and maintained in the linked list form. So here this is the structure of a different types of queues in a operating system. So the representation of the process scheduling is shown in this figure. So the queuing diagram represents the queues resources flow. So first we have a ready queue. From the ready queue, the process is selected and given to the CPU. Suppose this during the execution, the process is there is a two-way of things will happen. Suppose the process is completed, the process time is over means that goes to the terminate state. From the ready state, it goes to the running state. From the running state, it goes to the terminate state. But in during the execution, it has some interrupt in terms of an IO request, or the time slice will be expired, or it requires some new processes will create. So if there is any interrupt is occur, it comes out from that execution, and that could be placed in the respective queues. Suppose that process require some IO devices for execution means that executing process is interrupted, that come out from the CPU, and it goes to the IO device queue. So after the IO device request is sanctioned, that again that process is goes to the ready queue, not the running state. Suppose that executing process, suppose in the round robin phases, the each process are separate, have the common time slice for execution. So that time slice is expired, or means also that process is forcibly move out from that CPU and it goes to the consent queues. Suppose during that execution that process is want to create a new process, means the child process is created. After the child executed, that go to the ready queue. From the ready queue it goes to the running state. So these are all the interrupts will happen during the execution of the process in CPU. That interrupt could be intimated in terms of a system call. After that interrupt, that process is saved into the corresponding queues. If that that interrupt is completed, means that go to the ready queue and finally it executed and finally it go to the terminated states. So for that scheduling purposes, we have this different types of scheduler will record. In that we have three types of queues. So based upon the queue, the scheduler select the process and given into the particular execution. So in the short term scheduler, mean that is a CPU scheduler. It take the process from the ready queue and execute in that process in the CPU. Suppose long term scheduler or the job scheduler, it pick the process in the job queue and given into the ready queue. That is a long term scheduler. So during that the long term scheduler, it controls the degree of multiprogramming, but the short term scheduler, it produces the maximize the multiprogramming. So the processes, already I said that we have the two types of processes. It's an IO bound processes and the CPU bound processes. So the IO bound processes spend more time in the IO device execution. The CPU bound processes mean it spent more time in the CPU execution. So these are all the schedulers we need to execute any processes from the secondary to main memory. So I hope in this video we know that what is the process scheduling. So in terms of scheduling, what are all the activities will be done, then what are all the different types of queues and how the queues is maintained by the scheduler. Thank you.